All right, so if a company decides to increase spending on advertising, it would expect sales to increase. Now, at first, sales will increase at an increasing rate and then increase at a decreasing rate. So basically, this slows down. Now, the dollar amount X at which the rate of change of sales goes from increasing to decreasing is called the point of diminishing returns. So it's going to reach a point eventually where it's going to, no matter how much more you put into it, you're not going to get any more sales out. Now, this is also the amount at which the rate of change has the maximum value, and then the money spent beyond this may actually increase sales, but at a lower rate. So let's look at this example here. So it says currently a discount appliance store is selling 200 large screen TVs monthly. If the store invests X thousand dollars in an advertising campaign, the ad company estimates that the monthly sales will be given by n of x equals 4x cubed minus 0.25x to the fourth plus 500, and x is between 0 and 12. Now, when is the rate of change of sales increasing and when is it decreasing? And what is the point of diminishing returns and the maximum rate of change of sales? Now, graph n and n prime on the same coordinate system. All right, so let's do this. So first off, let's think about what is n prime. What is our first derivative? Okay, notice they gave it to us. They didn't put it in decreasing powers of x, so we're just going to write it as we have. We have a 12x squared minus, and then we're going to have 4 times that, so that's going to be what? Well, that's going to be just a 1, and so then it's going to be a 1 x to the third, so minus x to the third. Okay. Now we also need to find n double prime, second derivative. Well, that's going to be 24x minus 3x squared. All right. So all the different pieces we need to do now. What do we need to do? Well, we need to find out where all the zeros are going to be at. So if we take and factor out an x squared, maybe let's factor out a negative x squared so we have the positive here. That would give us what? Well, that would give us x minus 12, rewriting it, because if we have negative x cubed and then plus 12x squared, again, if we took out the negative so we can have a positive, that would be what we kind of get looking like here. Now, again, if we have that as a negative 3x squared plus 24x, what could we do? Well, we can pull out what? We could pull out a negative 3x, and then we'd have what? X minus 8. So here we have x is equal to 0 and x is equal to 12. Here we'd have x equals 0 and what? X equals 8. Okay, so those would be points we could use. And so let's go from there. And so with this, we can make a sign chart. And we have what, a 12 point, and we'd have what, a 0 point. And so we say -1, maybe we could choose a +1 and maybe a 13. Now, these are not going to have any problems, so those will be points with zeros. And if we plug in the -1s, then that's going to be positive. So these are going to be positive here no matter what when we plug that in. Plug in 1, that's still going to be positive values. And we plug in 13. Okay, so that's going to start giving us bigger numbers here. So those are going to give us negative values. Okay, and so that's going to be our f prime. So we're going to be increasing at this point all the way to here, and then we're going to be decreasing after that. Now, what about this one? All right, so we have 0, we have 8. I don't know. Now remember, we can only go up to 12. That's kind of our key point. So really, it's after this, we don't care. We really only care up to point here. So maybe let's look at all the way to 12 here. Let's choose, I don't know, some point here, maybe a 5. Let's choose some point here, -1. And again, 0 is kind of our bottom end. So really, we're only going to start at this point here, and we're going to go up to the 12. And so those points beyond it really don't matter too much. It's those points in between that really matter the most. All right, so these all work. So we can say 0 and 0. Now, if we plug in the negatives, those are going to be negative. If we plug in positives, those will be positives. Now, if we plug in 12, now that's going to start going negative. So those are going to go like that. So here we have what? Concave down. Here we have concave up. And here we have concave down again. Okay. So here is going to be a point of inflection. Here is going to be a point of inflection. Okay, so we have those. Um, Now let's see, what do we have? We have points of inflection. And now again, we're only going from 0 to 12. So let's think about what we have here. So there's going to be something like this. We have something out here maybe at 12. And so now we have to think about how our graphs are going to be. So this graph is going to go in which manner? So our n of x is going to be what? It's going to be some point. We're going to start probably at a higher point because of that 500. And we're not going to worry about what happens to the left at below 0. So we're going to go up until what point? Well, we're going to go up until we have a point here at 8. It looks like we're going to have a point of inflection. So somewhere around 8, and we probably should just draw this in and then put our point in here. We're going to go from concave up to concave down. So we're going to go up here. We're going to go up and then we're gonna go to down. And then we're gonna stop here because it's at point we're gonna stop. It's gonna start going down because we know our point here is gonna be a max at 12, and then it's gonna be kind of going down. So it's probably not exactly drawn to scale. It should be have more of a peak here, but that's okay. That's gonna be kind of a shape for, and that's gonna be our what? N of x. All right, so now what is our derivative looking like? Well, it's positive and it's going up and it's always going to be positive up to 12. So it's it's going to be something. And again, it's not going to be perfect, but uh, it's going to be up until our point of inflection, and that's going to be saying that we're going to be starting to go down there. And then we're still positive at that point here. So we're going to stop at that point, and because we're not going beyond that. So that looks probably something like our derivative. And so that one we called n prime of x. So it's going to look something like that for n of x and something like that for n prime. And this is going to be roughly our 8. Okay. So those are going to be what we get out of this. We know it's increasing from 0 to 8 and then decreasing from 8 to 12 because of this part here. Um, and then we just kind of get that from this. So let's see what it looks like if we graph it. And again, our graph is probably not going to be the best in the world. And let's actually turn on our derivative now because we're going to want to see what that looks like. And so our thing was 4x to the third, and then we had a minus 0.25x to the fourth. And then we had what, plus 500. All right. Now our window are going to be from 0, and let's only go to 12 because that's really where it was. Let's go by 2. All of our things were positive, it looked like. So let's go 0. And maybe, I don't know, again, I don't know what the highest one is. So maybe let's go to 1,000. Let's go by, I don't know, 500. Okay, now let's see what we have. Maybe we need a little higher. So maybe let's go to 5,000. There we go. And so that's kind of what we have. And again, I didn't know how it was going to do. I knew we were going to go up. We have a point of inflection somewhere here, which is also going to attach to our highest point, which should be about 8. So 2, 4, 6, 8. So that should be about there. That's our point of inflection. So we're going from concave up to concave down. This is going to be our max point. So after that, it should go down. And at this point, then that'll go below. And so, but again, we just wanted from 0 to 12, and that's going to be what we had. And going back to our thing, it kind of looks like that. It's not the best thing, but that's what it looks like here. Okay, so let's stop there. And I think that's all I have for you for this section. So hopefully that will help you get through this section.